Good morning to all my YouTube viewers. In this video, we like to discuss JEE Main 2020's remaining question paper, that is from question number 21 to 25. In these questions, uh, they are in integer type and filling the blanks type. Now, let us come to question number 21. A beam of electromagnetic radiation of intensity 6.4 into 10 to the power minus 5 watt per centimeter square is comprised of wavelength lambda equal to 310 nanometer. It falls normally on a metal. Work function is given phi equal to 2 electron volt of surface area of 1 centimeter square. If 1 in 10 to the power 3 photons ejects an electron, total number of electrons ejected in 1 second is 10 to the power x. Within bracket H equal to 1240 electron volt nanometer is given. 1 electron volt equal to 1.6 into 10 to the power minus 19 joules. Then we have to find out value of x. Now come to solution. Here tools require the incident energy equal to h nu, which is hc by lambda. Now concept of electron ejection from metal surface, that requires that incident energy should be greater than work function. Now E equal to hc by lambda. So hc is provided 1240 over 310 nanometer. From here we can get 4 electron volt. As this energy is greater than work function, it confirms that there will be a ejection of photo electrons. Electron emission will take place, that is the confirmation. Number of photons emitted per second is the amount of incident energy over energy required for each photon, energy contained in each photon, that will give you number of photons required, that is 10 to the power 14 number of photons are required to emit, photons are number of photons are available. Now number of photoelectrons emitted will be 10 to the power 14 over 10 to the power 3, because 10 to the power 3 number of photons required to emit 1 electron. Therefore, it will give you 10 to the power 11, that means x equal to 11, that is the answer. Next question, question number 22. A particle within bracket m equal to 1 kg slides down a frictionless track AOC starting from rest at a point A where height is 2 meter. After reaching C, the particle continues to move freely in air as a projectile. When it reaches its highest point P, whose height is 1 meter, the kinetic energy of the particle in joules, given G equal to 10 meter per second square. As the solution, as the track is frictionless, no frictional energy loss will take place. So change in potential energy will be equal to gain in kinetic energy, that is delta Ek equal to mg h1 minus h2, that will give us 10 joules. So, filling the blanks has to be done with 10 joules. Now, question number 23. A loop ABCDEFA of straight edge has 6 corner points having coordinates A 0 0 0, B 5 0 0, C 5 5 0, D 0 5 0, E 0 5 5, F 0 0 5. The magnetic field in this region is B equal to, that is 3I plus 4K Tesla. The quantity of flux through loop ABCDEFA in Weber is filling the blanks. Now, as we know, flux phi equal to B dot A. Now, area vectors for ABCD as well as ADEF are perpendicular to the areas. That means, for ABCD it will be along k direction, 25 is the area and 25k will be the direction of area vector. Now, for area ADEF it will be along x direction, which is perpendicular to that plane. Now, that means 25I plus 25k is the area vector, and vector V is provided, that is 3I plus 4k. The dot product will give us 175 Weber. So, filling the blanks has to be done with 175 Weber. Next question 24. Now, here a non-isotropic solid metal cube has coefficients of linear expansion 5 into 10 to the power minus 5 per degree Celsius along the x axis and 5 into 10 to the power minus 6 along y and z axis. If the coefficient of volume expansion of the solid is C into 10 to the power minus 6 per degree Celsius, then the value of C has to fill this gap. Now, as you know that volume we can write x, y, z. Here it is a cube, x equal to y equal to z. Now, we can have a partial differentiation of this, that is dphi equal to dx yz plus x dyz plus xy dz, and dividing this with the original volume, then delta v by v will come. Now, dx by x plus dy by y plus dz by z will come. Now, we know dv can be replaced by original volume, coefficient of volume expansion into temperature change divided by v, and similarly in the right side dx can be replaced by x alpha 1 delta t dt plus for dy we can write y alpha 2 dt, and for dz similarly z alpha 2 dt, because these two expansions are equal, both are alpha 2. Now, solving all, we can get alpha 1 plus 2 alpha 2 into dt, and comparing left right we can see that gamma will come, that is alpha 1 plus 2 alpha 2. Now, values are known. After putting values we can get 6 into 10 to the power 5 per degree Celsius. That means C will be 6. Now, come to next question, that is question number 25. A Carnot engine operates between two reservoirs of temperatures 900 K and 300 K. The engine performs 1200 joules of work per cycle. The heat energy delivered by the engine to the low temperature reservoir in a cycle is filling the blanks. Now, here we know efficiency we can write 1 minus T2 over T1. So, here it will give us 2/3. Again, efficiency means work done divided by input heat energy. Now, if we write down W by Q1 equal to 2 by 3, and we know that per cycle work done is 1200 joules. So, putting this we can get Q1. Thereafter, we can find out Q2, so that is Q1 minus W, that is 600 joules. So, filling the blanks has to be completed by 600 joules. Now, this ends the first shift paper which took place on 7th January, and next video will go for other shifts, other 5 shifts are left, and it will be coming very soon. So, please participate in the video, in the discussion. If you have any points to say, you can put some comment in the comment box, and also you may prefer to subscribe to motivate me. Thank you very much.